Hi, this is Stefano Zacchiaroli from Université de Paris and INRIA, and I'm going to present our proposed study on determining the intrinsic structure of public software development history, which is joint work with my student Antoine Pietri and my colleague Guillaume Rousseau. So the success of free and open source software and of collaborative development platforms such as GitHub and GitLab has given a wealth of public source code artifacts for amateur and empirical software engineering research. In particular, version control systems have been studied a lot, starting from the early 90s. However, most of the studies on version control systems have focused on either individual repository or a set of interrelated repositories. Only very recently, we have been in the condition to study all version control systems available out there, thanks to platforms like Software Heritage or World of Code. So the idea of this study is to look at the global network of all version control systems out there, actually of all the artifacts stored in all version control systems out there, and study the intrinsic structure of the resulting global graph. So we will start from the Software Heritage Archive, which is the largest platform out there in terms of archived version control systems, covering the most popular platforms for collaborative development or source code distribution. And specifically, we will use the Software Heritage Graph dataset, which is a graph view of the entire content of the archive, encompassing more than 100 million projects, more than 8 billion files, and more than 1.5 billion commits to this date. So what's interesting about this archive is that the view is indeed unified. So everything is deduplicated. So a source code file is stored exactly once, representing a single node in the graph, and you can see all the different directories that point to that file, no matter where they are. And the same goes on while you travel the graph up. So for instance, you can see all the different commits pointing to the same repository, pointing to the same directory, or you can see the same repositories containing the same commit, and so on up to the individual repository call. So you have a unified view, essentially, of the entire body of the source code that has been published out there in some version control system. So our approach here, our proposal, is to consider this graph as a complex network that results naturally from the human activity of software development and study it from the point of view of network theory using clustering techniques from network theory. So we'll study questions like the topology of the network. For instance, what is the distribution of in degrees, out degrees, and local clustering coefficient of the network. We'll study the modularity of the network. For instance, how can we break it up in connected components? And we'll study also the height of the network. So for instance, measuring the average length of the shortest path from nodes to leaves in the network. So we will answer these questions for both the graph as a whole and for relevant subgraphs. For instance, considering separately the file system layer that links together files and directories, or the development history layer that links together commits and releases. As execution plan, we will start from the most recent version of the Software Heritage Graph dataset that will be available at the time we start the study. We'll compress that graph using techniques mutuated from the web graph or social network graph compression, so that the structure of the VCS graph fits in memory. It has been recently shown that that can be done, and so we plan to use those techniques and do all the access on the graph on compressed graph representation in memory via the web graph Java API. So once the graph fits in memory, we will apply standard techniques for answering the three research questions about in degrees, out degrees, about connected component sizes, and about shortest path of the path of interest. So we expect that the findings will shed some light in various aspects that are interesting for MSR and user research. In particular, we will find out how this VCS graph, the global VCS graph, compares to other naturally occurring networks that are studied in other fields, like web graph or social networks. We will also determine what is the best technological approach to perform full-scale analysis of this corpus. For instance, if the global VCS graph is modular, it will be more appropriate to study it with distributed approaches, while if it is not modular, it would be more appropriate to study it using centralized approaches. Also, we'll determine statistical property of path lengths, which are useful as they are the limiting factors when indexing this global corpus for software program tracking and other use cases. So to wrap up, we will analyze the global version control system graph as a complex network with standard techniques. We will do so starting from the Software Heritage Graph dataset, compressing it, and we think these studies will be very helpful in comparing the VCS graph to other large networks and in determining how to best analyze all public code in future MSR and empirical software engineering studies.